Okay, so top of page 102 as well, all right? So we got sand accumulation, so that just means a gathering or build-up of sand, all right? Um, at the foot of a dune after storm erosion. So I just want to highlight that because after Dorian, Cabbage Beach again uh, showed signs of massive movement of sand towards the foot of the dunes, okay? So this is a natural process. Moving on quickly, okay? We got some more of the vegetation, saltwater, and so on. All right. So this vegetation, they soon cover a wide area and trap more sand. So we're still talking about the formation of our dunes. We got sand being blown up onto the back of the beach, being trapped by all this vegetation. Okay. The buildup of sand at this point is known as the foredune, the front of it. Okay, we'll look at a diagram in a little bit. And paves the way for another range of plants to establish themselves on the face of what will be the main dune. So as you move away from the water, if you stood in the water with your back to the ocean and started walking away, okay, you'll hit the foredune where there's some vegetation, and then behind that it'll get even steeper and you'll hit more vegetation again. Okay, some sand is blown through the first line of plants, okay, as the dune spreads. All right, and there's more vegetation, so the further back you go from the ocean, there's more vegetation, and that traps even more and more sand. All right, so it's just the same process: sand being blown in, collect and stopped by vegetation. All right, we got our spider lily and our sea oats again. Here the sand dune may reach as high as 10 or 12 meters. That's very, very high. Okay, so then behind the crest, which is the top, as we've already defined, behind the very top of our sand dune, then, okay, you've got even a bigger range of plants and vegetation. Sea grape, okay, the casuarina, which is an invasive species. It's not a good plant to have. All right, they'll be found back here, where they're fully protected from the sea. Okay, so once formed, the sand dune is a natural barrier against wind and wave action, and so protects the land behind it. And that's where you get all your vegetation and people starting to live and so on. So the sand dunes are a natural protection. All right. They also, as we've already discussed, they give rise to our ridgelands. Remember, our ridges are just solidified sand dunes, which have just cemented over time. Now, over here, I put down sand dune uses. Maybe not overly relevant for this topic, but it's always good to have a couple extra notes. So they're good for tourism and other structures, okay, maybe built on top of these because they're quite strong. They're popular environments for golf courses. They can create woodlands if there's enough vegetation. They also hold rainwater and can be used as an aquifer. This is quite common in Eleuthera. All right. The dunes provide protection for coastal roads. All right, and they also, let's move on to the next page. They can also create a screen or a block between the beach users and the traffic, so the beaches stay nice and quiet. All right. However, dunes are easily eroded if their vegetation is damaged. All right, so along West Bay Street and New Providence, all of those sand dunes have been lost. Just past Junkanoo Beach on the way to Fishray. Unrestricted growth of casuarina. Okay, so casuarina is actually poisonous to native species, so it's not a good plant. So things that remove the sand dunes is the casuarina plant is not great because it kills the other vegetation which catches the sand. Seawall construction we look at next week in lessons, and we build roads, we drive all over the dunes, we park up on them, all that kind of stuff. All right, so that's our sand dunes. Next, we're just going to briefly tip on to beaches. All right, so beaches. In general, the more sheltered bankside coasts will have fewer and narrower beaches than the exposed windward coast. So that's important. Our prevailing wind comes from the east. So windward is on the east side. So think about the east side of Eleuthera. That's where most, if not all, of the beaches are because we've got stronger winds and waves moving sediment onto the coast. All right. So what we'll do is we move on to page 104. So you will find most of the beaches, on the east side of the islands, okay? All right, page 104. So generally speaking, the larger the waves, the wider the beach, okay? Because the waves can carry the sediment that much further up the beach. So again, where our prevailing wind comes from, all right, from the east, so we'll have our waves coming in there and they can push further up the beach. So you'll have wider or longer beaches. All right. When I say that, I mean wider from where the sea ends to the back of the beach. All right. So why can we have a beach in one place and not another? There's three factors: supply of sediment, the transport, and the trap for the sediment. So sediment is generated in shallow water, particularly on and behind the reefs. So beaches are not likely to form where there's deep water right offshore. So think of Clifton. Right out of Clifton, there's quite deep water, so you won't get a beach there. We need protection from reefs and shallower water. Okay. Transport is needed to ensure that the sediment reaches the beach. Wave action is the most important means of transport. All right. And the tides and the winds, they only help to build up really the sand dunes. Okay, the tides change twice a day. All right, so we get the sand exposed and not exposed, and the wind blows it up into dunes. All right, but it's the waves that transport. So you have to have waves like we do on the east side of islands for the transport to happen. Okay. So, and then the final one is, sorry, we're on page 105 now, as you can see. Finally, the sediment has to be trapped or it'll be swept away by the longshore drift. All right. So a typical beach trap will be between two headlands, which will prevent the sand from escaping. So again, you need some points. You don't want a perfectly straight coast. It has to curve off at one end or so. Again, Cabbage Beach is a good example. At both ends, it's got a little curve where the longshore drift will stop. All right. The north coast of New Providence is also a good example. It's been eroded a bit now, but if you look at it, it kind of goes in this shape. All right, with our headlands out like this, and then the beaches, Cable and Saunders and Love Beach, are in between all of those small headlands. All right. Okay, and just to finish off again, we've already gone through our spits, bars, and tombolos. Okay. These are distinguished from beaches by having water on both sides, or at least two sides. So a bar usually develops in a bay, okay, instead of a beach, if the waves lose their energy before reaching the shore. All right, so the sediment is then deposited in shallow water and eventually builds up to trap a lagoon behind it. All right, we'll look at a little diagram in a second. For some reason, they've put the diagram to this on page 95, so you can write that note down, and we'll go back to page 95 shortly. A spit is distinguished from a bar by being attached to land at one end. So a bar attaches on both ends, a spit on one end. Then the tombolo is similar to a bar, but when one end is joined to an offshore island and the other to the shore. All right, so it forms a natural causeway or route. Lyford Key was really a key, and boats could pass inside it at high water. All right. Now the land is 3 meters above sea level, and only the name remains. So the reason it's called Lyford Key is it used to actually be a small island off the coast of New Providence, but naturally connected up to it through two tombolos. We're going to jump to page 95 very quickly and just look at some of the formation. Okay, diagram on page 95 here. All right, I've written a link to text on page 106. All right, so again, very simple, like what we saw earlier. Okay, prevailing wind as always coming along, moving our waves in this direction. All right, so you've got your longshore drift will be moving in the same direction as well. All right, so again, you can get a deposition of sand out here like a sandbar, which can actually connect the whole thing up and leave a lagoon behind it, which will eventually turn into land. Okay, here's just where we get our beach, just along, and remember, look, it's trapped between two headlands. All right, our spit then, the longshore drift comes along, okay, and it deposits material out here. There's a change in direction in the coastline. The material gets dropped, and in behind here we get our salt marsh or our mud flats building up, and eventually, as seen in the photos earlier, people will live on this. The same happens here. You get more longshore drift coming along, change in direction, it doesn't know what to do, so it deposits its sand all here and reaches out to the little island behind it, or sorry, the island off coast. Behind this little tombolo then you get more land built up in the same way. All right, so again, a good little diagram to look over. What we're going to do is just spend 2 or 3 minutes looking at some slides. All right, I know there's a lot of videos today, but there's a lot of information, so just a couple of slides and then we're finished.